Chapter 1 starts out with expressions and variables. We're going to run through a few of the vocabulary words because we will be using these throughout the year. Our first vocabulary word is numerical expression, and a numerical expression consists of numbers and operations. So you could have 4 times 10, and you could write 4, got my pen, you could write that as 4 times 10, but now that we are in algebra, we want to write it without using the multiplication symbol because that could easily be mixed up with an X. Maybe that one I just wrote couldn't. So we want to get used to writing 4 and the parentheses 10. When there's not an operational symbol there, that means 4 times 10. Or you can write it as 4 and you can use the, doesn't know that I want to draw a dot there instead. And a dot, that's an ugly dot, but I think you can see it, 4 times 10. Our next expression is variable, and variable is just a letter that is used to represent one or more numbers, or something that we might solve for. Probably the one that's used the most is the X. You'll notice my X has some curved tails to it, again, to not get it mixed up with the multiplication symbol. A variable expression would involve numbers and a variable. So we could use 4x. That would be a variable expression. That would be 4 times 10, or 4 times x, similar to my numerical expression, which was 4 times 10. You'll notice I didn't have to put parentheses around it because we see it just right next to each other, and that means that we have to assume that there's an operation, and that operation is multiplication. And then evaluate, silly as it seems, sometimes we forget that, and that just means that we're going to solve. It's a word for solving. We use evaluate when we want to say, usually they'll say, find the answer when x is equal to, or when the variable is equal to something. So that's where we get the numerical, that's where we get evaluate. Right, going to the next slide here. All right, so in example 1, we're going to talk about 4 times d. And you're going to see right here, in this particular example, they use the dot to show the multiplication. So evaluate 4 times d, and there you see the word when. Whenever we see the word when, it means it's just going to be a substitution. So evaluate 4 times d when d is 120. That would be the same as writing 4, and you notice I'm using the parentheses. We want to get used to using that. 4 times 120. And 4 times 120 is 480. Example 2, we're going to have 2 variables, an x and a y. Same procedure, we're just going to use substitution because we see the word when again. So our first example is saying x plus y, and our x is 10, and our y is 4. So I'm just substituting that in there. 10 plus 4, and that's going to equal 14. When we get to the next one, I have x, y. I don't see an operational symbol. I see them right next to each other, so that means it's going to be multiplication. So the x is 10. Because I'm using numbers, I'm using the parentheses times 4. And if we haven't seen this one enough, 10 times 4 equals 40. All right, easy enough. Good way to start back in. I'm going to pause this a minute. Looks like we might have the wrong. Okay, we're recording again now. And I'm going to go ahead and I'm going to do just a couple more of those. This time we have x equals 6 and we have y equals 12. So in the first one we only have one variable. So I just simply substitute that in. 12 plus 8. 12 plus 8 is 20. Another thing you're going to notice in algebra is we solve going downwards. And you should get used to that. If you are conscious about saving paper, you might have 2 columns on your paper, but we're going to work downwards. The next one is 9 minus x. So again, we'll keep that numerical expression as 9 minus, and we'll substitute in our x. 9 minus 6 is 3. The next one, we're using the 2 variables again. Just substitute them in, and that's why we substitute just right below it. 12 minus 6 Pretty easy mental math here. And xy, again, that means multiplication. So I'm substituting the 6 in for x, the 12 in for y, and then I use the parentheses. And this one might take you a little bit. 12 times, or 6 times 12, or 12 times 6 is 72. All right, and then our last example is going to be about writing variable expressions. So we're going to have a little story problem here. You plan to divide, notice you have an operational word right there, the 120 players, underline that important information, in a baseball league into teams with the same numbers of players. So write a variable expression for the number of teams if you know the number of players on each team. So the thing we do not know is the number of players on each team. So we have P that's going to represent the number of players. Many times it's a play on words, so we're using the variable P. The word divide indicates division. So our variable expression is going to be, we want to find out the number of teams. We know the number of players in the league. That was the 120. And we're going to divide that by the number of players on a team. And we said that was going to be P. Now you could write that with the diagonal, like I have it in the word part, or you can write it simply as the horizontal line. 120 divided by P. The reason this is a variable expression is as we find out the number of players on each team, we could keep changing it. So if I say I want 12 players on each team, then I would substitute P as 12, and I'd have 120 divided by 12, and then I could solve for my number of teams, and that would be 10. Okay, in the same way, if I have 120 players in the league, which we know, but this time I'm playing something that I need 10 players on each team. Well, then I would be able to say that the number of teams I could have is 120 divided by 10, which is 12. So this was just a reminder about using variables, an introduction for the first lesson.